So now let us start solving question number 12. In question number 12, they are saying that there is a circle K and the center of this circle is at the point of origin, okay? That is the intersection of x-axis and y-axis. And somewhere there are these 3 points A, B and C, and we have to show that they lie on this circle, okay? Fine. Now we can see the coordinates of point A are 1, -8. That means it will lie in the third quadrant. Okay, point A will be lying here somewhere in the third quadrant. Okay, let us say this is point A. Then point B is -4, 7. That means it will lie in the second quadrant. Okay, point B. And C is -7, -4. That means it will lie somewhere in the quadrant 3. Okay. Now, if these 3 points are on the circle, then their distance from point O should represent the radius of the circle. Yes or no? And if that is the radius of the circle, that means their value should be equal. Okay. What I mean to say is that the lengths of segments AO will be equal to length of segment BO, and that will also be equal to the length of segment CO, because all of them are the radius of the circle if these points are indeed on the circle. Okay, so once we prove this, we can say that yes, these points lie on the circle. Okay, for this obviously we will be using the distance formula. Okay, and what is the distance formula? The distance formula, let us write it and see. Okay, fine. So in short, suppose if I say that there are 2 points where the coordinates of first point is x1 y1 and the coordinates of another point is r y x2 y2, then the distance between these 2 points will be given by the formula. Distance between these 2 points will be equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is the formula that we will use. Okay, so if we want to find out the length of AO, then the coordinates of A, let us consider them as x1 y1. Okay, so 1 comma -8 will be our x1 y1, and O, that is 0 0, are our x2 y2. Okay, so I am applying the distance formula directly now. So x2, that is 1 minus 0 the whole square plus -8 minus 0 the whole square. So that will give us 1 square plus -8 square. Okay, so that will give us 1 ka square is 1 plus -8 ka square, that is 64. Okay, the squares of negative numbers are also positive. Fine, so that will give us under root square root of 65. That is the length of AO. Similarly, let us quickly find the length of BO. So for that, again we will have to use the distance formula. Now we will consider our coordinates of B, that is -4, 7 as x1 y1. Okay, and this is x2 y2. Fine. So again we can do that. -4 minus 0 square whole square plus 7 minus 0 the whole square. So that will give us -4 ka square plus 7 ka square. So that will be -4 is square is 16 plus 7 ka square is 49. Okay, so when we add them up, we will get 65. So again this is same, it is square root of 65. Okay, then length of CO, okay, the coordinates of C are -7 and -4. So let us quickly solve this. -7 minus 0 the whole square plus -4 minus 0 the whole square. So again that will be simply -7 square plus -4 square. So that will be similar to the BO section, that is 49 plus 16, that will be square root of 65. Okay, so here because lengths of AO, BO and CO are equal, okay, we can say that yes, all these 3 points lie on the circle having the center as origin. Okay, so what is the radius of the circle? K. Therefore the radius of the circle K is under root 65 units. Under root 65 units. Okay, here we have to write units all the 3 places. Okay, under root 65 units. Fine. That is the first half of the question. Now let us quickly go to the second half. That is, given the points D, that is -5, 6 and E 0, 9, check whether D and E lie within the circle, on the circle or outside the circle. So this we have to find the distance of these points from the center. So first let us find DO. Okay, so we are considering the coordinates of point D as x2, y2. Okay, so that will give us -5 minus 0 the whole square plus 6 minus 0 the whole square, right? So -5 minus 0 will be -5 uska square and 6 ka square. So -5 square will be 25 plus 6 square will be 36. So that will be 5 plus 6 is 11 and that will give us 61. So square root of 61. Okay, 61 square root units. That is the value of distance DO. Now this distance you can see is smaller than the radius of the circle. That means this point will lie in the circle. Okay, it will lie within the circle. Therefore now we can write it here that the length of DO is smaller than the radius of the circle. Okay, therefore point D lies within the circle, that is what we will write. Okay, now let us quickly go to length of point EO. So for this also we will consider the coordinates of E as x2, y2. So that means 0 minus 0 the whole square plus 9 minus 0 the whole square. That will give us under root 0 ka square plus 9 ka square. So that will be 0 plus 81. Okay, so it is square root of 81. Now actually square root of 81, we know that it is 9. Okay, so that is 9 units. Fine, but because the radius is given in square root, we will also consider this only. Okay, we will not consider 9. So here we can see that the length of EO is actually greater than the radius of the circle. Your radius of the circle is under root 65 units and EO is under root 81 units. So therefore this point, point E lies outside the circle, K. Okay, so that is the answer of this question number 12.